Yeah, so today I would like to discuss one question based on the number theory which occurred in CSIR. So what it tells you is that for any positive integer n, omega of n denotes number of prime factors of n with a counted multiplicity. Means suppose let me take n equals to 1. What is omega of 1? There is no prime factor of n, right? So that means 0. N equals to 2. So how many prime factors of 2 with multiplicity? Only 1. N equals to 3. How many prime factors of 3 with multiplicity? Only 1. Suppose n equals to 4. How many prime factors of 4 with multiplicity? This 4 can be written as 2 square. Therefore multiplicity is 2 is repeated twice. Therefore therefore omega for 4 is actually 2. N equals to 5. What is omega of 5? 1 only. Suppose n equals to 6. What is this? So 6 can be written as easily 2 into 3. Therefore there are 2 prime factors. Therefore this is 2. So that means this is what actually omega of n definition. I hope you understand omega of n definition. Now later we'll discuss main question. You are given that n is equals to p plus 2, p plus 4, where p is a prime number which is bigger than 3. Which of the following statements are true? So this omega of n should be always bigger than or equals to 3. Right? So we can solve these questions in 2 ways actually, in fact. Basically, suppose if you start with p bigger than 3, that means what? P can be actually 5. Therefore what is n? 5, 5 plus 2, 5 plus 4. That means what? 5 into 7 into 9. That means 5 into 7 into 3 square. Therefore what is omega of n? So 2 here 2 1 1. That means what? Omega of n is 4, which is always bigger than 3, right? And p equals to 7, because p is what is p? P is a prime number which is bigger than 3. The possibilities of p you need to check and check the corresponding values of omega of n. That is the strategy of the problem, right? So n equals to 7 into 7 plus 2, 7 plus 4. That means 7 into 9 into 11. That is 7 into 11 into 3 square. Therefore what is omega of n? Again, so that is exactly for 4, which is always bigger than 3. Whenever p equals to, the next prime number is what? 11. Therefore n equals to what? 11 into 11 plus 2 into 11 plus 4 is exactly 11 into 13 into 15. That is exactly 11 into 13 into 3 into 5. Therefore how many prime numbers appeared in n? Therefore omega of n is equals to what? Actually 4. It's always bigger than 3. Now continuing this process, what you observe that actually by induction, omega of n always bigger than 3. Always bigger than 3. So this answer is always right. Now there exists a prime number p bigger than 3 in such a way that omega of n equals to 3. This is possible? No, by this argument you have seen. And p can be a p can never be the smallest prime divisor of n. Yes, actually, see what are the prime divisors of n here? For the first case, 5 is a prime divisor of n, and 7 is a prime divisor of n, and 3 is a prime divisor of n. So what is the smallest here? 3 is the smallest prime divisor of n. In this case, 7 is a prime divisor, 11 is a prime divisor, 3 is a prime divisor. Which is smallest among this? 3. In this case, 3 is the smallest prime divisor of n. but 3 is always less than p. So therefore 3 is the smallest prime divisor of n, right? Therefore p can never be the smallest prime divisor of n. This is actually what right, because 3 is the smallest prime divisor among all prime divisors of n. This is wrong. So this is what actually answer. So this is one way. It means guessing a problem using a so by induction one can solve this question. But by mathematically, what you do is that this is second method. Actually, p bigger than 3. Therefore, p is a prime number. P bigger than 3. By division algorithm, I can divide p by 3. This is I can have a quotient. I can have a remainder. Therefore, p can be actually what 3k plus r, where r lies between 0 to 3. So what are the possibilities of p? Whenever r is equals to 0, p equals to 3k, right? As you know that actually p bigger than 1, p bigger than 3, that means 3k bigger than actually 3, k bigger than 1. Therefore p is not a prime number. P is not a prime number, right? Why? Because 3 is a factor of p. Of course k also factor of p. So p has other two factors other than p. Therefore p cannot be a prime number, which is a contradiction. Therefore if you take r is equals to 0, we get a contradiction. Therefore this case is impossible. If you take r equals to 1, what is my p? My p is actually 3k plus 1. Therefore what is my n? N is equals to p, p plus 2, p plus 4. What is p here? 3k plus 1, 3k plus 1 plus 1, this is 3k plus 3, this is 3k plus 1 plus 4, that is 3k plus 5. Therefore what is this? This is 3k plus 1 into 3 into k plus 1 into 3k plus 5. So there are two possibility for each number. Either it is prime or not prime. Either it is prime, this 3 is a prime here. K plus 1 is either prime or not prime. 3k plus 1, 3k plus 5 is either prime or not prime. So therefore, how many possibilities? So 3k plus 1 either prime or not prime. 3 is always prime. K plus 1 is either prime or not prime. 3k plus y is either prime or not prime. So therefore, omega of n minimum number is 4, right? Because 1, 2, 3, 4. Therefore, omega of n is always bigger than or equals to 4. In this case, 3 is a factor of n. Therefore, 3 divides actually n. 3 is a prime factor of n. And also, if you take r is equals to 2, p is equals to what? 3k plus 2. So what is my n? 3k plus 2. 3k plus 2 plus 2. That is 3k plus 4. 3k plus 4 means 3k plus 2 plus 4. That is 3k plus 6. This is actually what? 3k plus 2. 3k plus 4. 3 common plus 2. Right? Again here 3 is a factor of n. Of course, either it is prime or not prime. 3 is a prime. This is prime or not prime. This is prime or not prime. So therefore omega of n always bigger than or equals to 4. So what you observe in all cases, 3 is a prime factor of n, which is of course smallest, because actually as you know that p bigger than 3, and all cases omega of n bigger than or equals to 4. So therefore this is impossible, because omega of n always bigger than or equals to 4, right? This is possible because omega of n bigger than or equal to 4 means what? I can take omega of n is 4, 5, 6, 7. So in all cases it satisfies, right? And p can never be the smallest prime divisor of n, because actually 3 is the smallest prime divisor of n. So with this I conclude the lecture. Thank you.